Hey everyone, ready to dive into something pretty amazing. We're tackling learning and memory today.
Always a fascinating topic.
I know, right? And we've got this super cool physiology handout. It's by Dr. Rasha Eldeeb.
Oh, nice.
Yeah, it's like a roadmap to how our brains actually learn. Our mission today. To unpack the different types of learning and memory, how they work, and what makes them, well, stick or fade away.
The million-dollar question.
Right. So let's start with learning. The basic definition, like how do we acquire knowledge? How do we develop new responses? All that good stuff.
Well, think of it this way. Your brain has two main paths for learning. There's non-associative learning,
Okay.
and then there's associative learning. Non-associative is basically responding to one thing over and over.
Okay. So that's one stimulus.
Exactly. And then associative, you're connecting different things.
Okay, so relationships.
Relationships, yeah.
Cool. Okay. Let's unpack non-associative first. I'm already interested.
Yeah. It's all about how your reaction to a single stimulus, just one thing, changes over time. Like, you were talking about a dripping faucet. At first, it's like, ugh, so annoying. But eventually, you just tune it out.
Just block it out.
Yeah, it's your brain going, this isn't important. I'm going to learn to ignore it. And that, my friend, is habituation.
So my brain is basically hitting mute on the dripping faucet. But how does that actually happen in my brain? What's the science behind it?
Chemicals. It's all about the chemicals.
Where?
Specifically, a decrease in calcium at your nerve endings.
Interesting.
So less calcium means those nerves are less likely to fire, and the signal gets weaker.
So my brain is literally rewiring itself to ignore that drip. Fascinating. But what about when the opposite happens? When a repeated stimulus becomes more noticeable, like you watch a scary movie and suddenly every little creak in the house makes you jump.
Right. That is your brain doing sensitization.
Okay.
So instead of decreasing, calcium levels increase at those nerve terminals.
Oh, interesting.
Yeah, it's like they're on high alert now, ready to fire at
Yeah.
the slightest provocation, and they're linked to something meaningful. In that case, it would be fear.
Oh, so it's like habituation is hitting the mute button and sensitization is turning up the volume. It's really amazing how adaptable our brains are to what's going on around us.
Right. And it all leads to the big one, memory. You
Yeah.
can't learn anything without memory. It's the ability to store information, but also to recall it.
Okay, so memory is the vault where all this learned information gets stashed.
Yeah.
But are there different types of vaults?
Oh, for sure. You've got your implicit memories.
Okay.
These are subconscious, they're reflexes, skills. Think of riding a bike or typing without looking at the keys.
You just do it.
It just do it. You don't even think about each step.
It's almost like it's embedded in our muscles, muscle memory.
Exactly. And then there's explicit memories.
Okay.
Explicit memories are the facts, events, knowledge that we consciously recall. Like, what did I have for breakfast? Or what's the capital of France?
Okay, so implicit is the automatic stuff, and explicit is what we have to really think about.
Got it. But how does our brain, choose which type of memory to use?
Well, it depends on the info, how it was learned. But here's the cool part. With practice, with repetition, those explicit memories can actually become implicit.
Well,
Think about when you were first learning to drive.
oh my gosh, yeah.
Every single step was a thought, and now you don't even think about it.
It's second nature. Wow, so my brain is basically upgrading those memories from manual to automatic.
That's a great way to put it.
That's so cool. Okay, so you've got implicit versus explicit, but there's more to memory than just that, right? We also talked about how long memories last.
Right. We categorize memories based on their duration.
Okay.
We've got immediate memory, primary memory, and secondary memory.
Okay.
And each of those has a different role in how we process information.
Okay. I'm hooked. Let's start with immediate. What's that all about?
Immediate memory is like a fleeting snapshot,
Oh, okay.
just for a few seconds. Okay.
It holds on to sensory information. Think you glance at a phone number, you got to remember it just long enough to dial it.
Oh, yeah.
That's immediate memory.
So it's like a super short holding pattern for my brain. But how does it even hold on to anything for even that split second?
So there's a couple of ideas about that. One is that the signal keeps bouncing around in a loop,
Oh, wow.
kind of like an echo, and that preserves the information for a short time.
That's amazing. But if that information's important, how does it move from that super short-term holding pen into something more lasting?
Well, then it graduates to primary memory.
Okay.
This lasts for minutes to hours. It's the stuff you're actively working with right now, like that phone number. You keep repeating it until you can dial it.
Yeah.
Think of it as your mental workspace. constantly updating.
So it's like my brain's RAM, limited capacity, but like super fast access.
Exactly. And when you keep repeating that number, you're strengthening the connections between neurons.
Okay.
That's called postsynaptic facilitation.
Big words.
I know, right?
Okay, so it's basically making those pathways more responsive so I can hold on to the information longer.
Exactly.
So repetition is like weightlifting for my synapses.
I like that, yeah.
Okay, so we've got immediate, we've got primary. But what about the memories I want to keep for years, for a lifetime? Where do those go?
That, my friend, is secondary memory.
Okay.
Long-term storage, huge capacity, maybe even unlimited, childhood memories to like complex knowledge about the world.
That's incredible. So it's like my brain's hard drive storing all those precious files away. But does everything from short-term memory make it into long-term storage?
Not necessarily. Only the stuff that we decide is important, the stuff we rehearse that we find meaningful.
Makes sense.
That gets the VIP pass to the long-term vault. And even then, it's not always easy to access. We've all had those tip-of-the-tongue moments.
Ugh, the worst.
Yeah.
But it's fascinating to think about those memories still being in there somewhere, just waiting for the right cue to come back.
Exactly. Sometimes, though, there are some deeper issues with memory retrieval. That's when we see things like amnesia.
Ooh, amnesia. Everyone's heard of that.
Yep.
But it's not always like in the movies, right?
No, not at all. Amnesia just means memory loss. But there are different types. You've got retrograde amnesia.
Okay.
That's where you can't recall recent memories, often after an injury. Think of it like your brain's recent files getting corrupted.
So that's why people might have a blank spot after a concussion.
Oh.
Those recent memories are more vulnerable.
Exactly. And then there's anterograde amnesia.
Okay.
You remember the past, but you can't form new long-term memories. This is often linked to damage in the hippocampus. That's a brain structure that's crucial for making new memories stick.
So it's like your brain's save button is broken. You can experience new things, but they don't get stored properly.
You got it. And then there's psychogenic amnesia. That one's triggered by extreme stress.
Oh, wow.
Ever heard of someone blanking on a traumatic experience?
Yeah.
That could be psychogenic amnesia, and thankfully it's often treatable.
Wow, it's incredible how stress can impact our memories like that. Okay, so we've got retrograde, anterograde, psychogenic. Any other types?
You bet. Global amnesia.
Okay.
That's a combination of retrograde and anterograde.
Oh, so more extensive memory loss.
Exactly. It's like both your recent files and your save button are malfunctioning.
That sounds scary.
It can be.
But even in those situations, our brains are pretty incredible, right? There's often potential for recovery.
Oh, absolutely. Understanding those different types of amnesia, it helps us appreciate how complex memory is, how precious and intricate these processes are.
This has been mind-blowing already. And we've only just dipped our toes into this amazing world of learning and memory. It's incredible to think about all these processes working together to shape our experiences, to shape who we are.
Right. And the thing is, we've barely scratched the surface.
I know there's so much more to explore, but this is a pretty great foundation to build on.
Definitely. A great starting point.
All right, Memory Explorers, we're back. Ready to delve even deeper into this fascinating world of learning and memory.
We've laid the groundwork, talked about different types, the basics.
Yeah, but now it's time to, zoom in on the mechanics. How do memories actually form? How do they stick around in our brains?
Right. Get down to the nitty-gritty.
Exactly. It's got to be more than just magic, right? Like what's happening at the cellular level when we learn something new or have a new experience?
You're talking about neurons and synapses?
Okay.
Those communication networks in our brains.
Oh.
Tiny messengers, zipping around, transmitting signals, making connections.
So every time we learn something, those pathways get activated.
You got it.
And then the more we practice, the more we revisit that information, the stronger those connections become. Kind of like, building a muscle.
That's a great analogy.
The more you use it, the stronger it gets.
Right. And as those connections strengthen, signals travel more easily along that pathway.
Okay.
That's how we form memories, how we form habits.
It's like those neural pathways become so well-trodden, the information just flows effortlessly.
Exactly.
But we were talking earlier about, those short-term memories becoming long-term memories. How does that transition happen?
That process is called consolidation.
Okay.
That's where those initially fragile short-term memories, they get transformed into something more stable, more lasting.
Consolidation. It's like packing those memories up and shipping them off to long-term storage.
That's a good way to think about it. And during this consolidation process, there are actual changes happening at the molecular level.
Oh, wow.
Especially in those synapses. the strength of those connections between neurons.
So like those synapses are getting an upgrade,
Yeah.
becoming more efficient.
Exactly. There are like proteins being released that can boost the communication between neurons.
So our brains are literally building new structures to house those memories.
Pretty cool, huh?
That's wild. You mentioned the hippocampus earlier. What role does that play in consolidation?
The hippocampus. Think of it like a librarian. It takes those new memories, it sorts them, categorizes them, links them to what we already know.
So it's not just storing them away. It's like trying to make sense of the new information.
Right, linking it to existing knowledge, making connections. It's like tagging a photo on social media.
Oh, yeah.
You're linking it to other people, places, events.
So you can find it more easily later. That's a perfect analogy.
Yes.
But what happens if the hippocampus gets damaged?
Well, then we might see anterograde amnesia.
Right.
Remember, trouble forming new long-term memories.
Because the librarian's out of commission. Those new memories are just floating around.
Exactly.
That makes so much sense now. Okay, so let's say the hippocampus is working perfectly. We've got all these memories stored away. How do we actually pull them back up when we need them?
That's retrieval. Reactivating those networks that formed when we first encoded the memory.
So it's like retracing those well-worn paths in our brains.
Yeah, like finding your way back to a familiar spot.
And the more we access a memory, the easier it is to retrace that path.
Exactly. That's why practice and repetition are so important.
Makes sense, like strengthening those retrieval routes.
Yeah.
But retrieval, it's not always perfect, right?
Unfortunately not. Memories can get tweaked, distorted a bit along the way.
Oh, tell me about it. Like when you remember something differently from how it actually happened.
Oh, yeah. Our memories aren't perfect recordings. Think of them as more like reconstructions. Every time you retrieve a memory, you're essentially rewriting it a little.
Wait, so every time I remember something, I'm actually changing it. That's kind of trippy.
It is trippy. Our memories are constantly evolving, shaped by our current perspective and, everything we've experienced since that initial memory formed.
So we need to be, careful about taking our own memories at face value.
For sure. There's room for interpretation.
Yeah.
And it's why, eyewitness testimony can be so tricky. Our memories are influenced by all sorts of things.
Right. So we talked about some strategies for improving memory, making those retrieval processes more reliable.
Exactly. Things like spaced repetition, active recall.
Okay, yeah, those are good ones.
Spaced repetition, you spread out your study sessions, give those pathways a chance to solidify.
Like letting cement dry.
Exactly. Active recall, that's testing yourself, explaining things to others.
It forces your brain to work.
Exactly.
I think a good brain workout.
It is.
Okay, so spaced repetition, active recall. What about sleep?
Sleep is crucial for consolidating those memories.
Really?
During deep sleep, your brain's processing, organizing everything you learned.
Oh, wow.
It's like a filing system, working overtime while you're snoozing.
So my brain is a super efficient filing system. I love it.
It is. Sleep helps those connections get stronger, memories get more stable.
Okay, so sleep is basically a superpower for memory. I am never going to feel bad about hitting the snooze button again.
Well, quantity matters, but quality matters more. Good sleep environment, regular sleep schedule.
Sleep hygiene. Got it. What else can we do to improve recall?
Here's a big one. Forgetting is natural.
Wait, seriously. Forgetting can be a good thing.
Yeah. Your brain's always sorting through information. Getting rid of what's not relevant anymore.
Okay.
So you can focus on what matters. Think of it like decluttering.
Like my brain is doing a spring cleaning.
Exactly. Make room for new stuff.
But even if we do forget something, does that mean it's gone forever?
Not necessarily. Often those memories are still there, just hidden away. You just need the right retrieval cue to unlock them.
Retrieval cues. What are those again?
They're like triggers.
Okay.
Help you access those tucked away memories. It could be a smell, a song, a visual image, even an emotion. Anything that was connected to that memory
Oh, that's interesting.
can help bring it back to the surface.
So if I'm trying to remember something, I should try to recreate the situation where I learned it.
Exactly.
Like if I'm trying to remember what I was doing on a specific day, maybe listen to the same music I was listening to back then.
There you go.
Those cues can make a big difference.
Absolutely.
Wow, this is all so fascinating. Okay, so we've talked about so much, different types of learning and memory, how those memories are formed, consolidated, retrieved, how we can boost our recall.
A lot to unpack.
It is. Before we wrap up this part, anything else we should cover about how we can use all of this in our daily lives?
Oh, yeah, for sure. One of the most important things to remember, memory is a lifelong process.
It doesn't just stop when we graduate.
Not at all. We can learn and grow our brains throughout our lives.
So it's never too late to learn something new or to improve our memory.
Never too late. Our brains are incredibly adaptable. We call that plasticity.
Okay.
It means we can keep forming new connections, learning new things, even as we get older.
That is good news.
Right, yeah.
So there's always hope for expanding our knowledge, keeping our minds sharp.
Always. The more we challenge ourselves mentally, the more we stimulate those pathways, keep our brains healthy, active.
So learning isn't just for kids.
No.
It's for everyone at every stage of life. That's a great reminder.
And learning and memory, they're more than just facts. They shape who we are, how we connect with others, how we experience the world.
That's beautifully said. All right, listeners, go out there, embrace the power of learning, keep those memories flourishing. We'll be back to talk about some super practical ways you can use all of this knowledge to really level up your learning game. Okay, so we've done it. We've explored this incredible world of learning and memory.
All the different types, how it all works.
The strategies for improvement, even what happens when things go wrong, like amnesia.
Right.
But now, for the big question. How do we use all this knowledge?
Right. How do we apply it?
Exactly. We've got all this amazing science, but what are the practical takeaways? How can we learn more effectively, remember things better?
Become super learners.
Yeah.
Well, one of the biggest things to remember is that learning, it's not passive. It's not something that just happens to you. We have to really engage with the information.
Okay. So no more zoning out during lectures or just skimming articles. We need to be more intentional.
Exactly. You want to absorb that information. Make it stick. You got to be an active participant.
Okay. So that means using those strategies we talked about.
Yep.
Spaced repetition, active recall, teaching what you've learned to others.
All of that. Those techniques really make your brain work harder. And that's a good thing.
It's like the difference between watching a workout video and actually hitting the gym yourself.
Exactly.
Okay, so active learning, check. What else?
Context matters a lot.
Okay.
Those memories you're building, they're not just isolated facts. They're connected to your experiences, your emotions, the environment you're in.
So it's not just what we learn, but where and how.
Exactly. Think about it. If you learn something in a specific room, you might remember it better when you're back in that room. Or if you link information to a strong emotion, that emotion can be like a trigger to help you remember it later.
So our surroundings, even our feelings, can affect how well we remember things.
Big time. And it means we can be strategic about it, create environments, experiences that boost our learning.
Makes sense.
Like if you focus best in quiet spaces, well, find a quiet space to study. If music helps you concentrate, put on some tunes.
So pay attention to what works best for you. Set yourself up for success.
Exactly.
Okay, active learning, check. Context matters, check. What else should we keep in mind?
Everyone learns differently.
Oh, yeah.
There's no one size fits all. What works for one person might not work for another.
Right. Like some people are visual learners, some people are auditory learners, some people learn best by doing.
Exactly. The key is to figure out what works for you.
That's such great advice. We need to be more aware of our own learning styles.
Absolutely. And if you're struggling, don't be afraid to ask for help. There are so many resources out there.
Tutors, study groups, flashcards.
All sorts of tools and strategies.
Oh, awesome. Okay, active learning, context, finding your own style, all great tips. But what about those moments when our memory just blanks? What can we do to improve our recall in those situations?
Well, first, remember that forgetting is normal. It doesn't mean you're doing something wrong. It's just how our brains work.
Right.
Your brain's always filtering, pruning information, getting rid of the stuff that's no longer relevant.
Okay.
So you can focus on what is.
So it's like my brain is making space for new experiences.
Exactly. And even when we forget something, it doesn't mean it's gone forever. Often it's just a matter of finding the right retrieval cues.
Those triggers.
Exactly. It could be a smell, a sound, a place, a feeling, anything that was linked to that memory.
Right.
And it can bring it right back.
So if you're having trouble remembering something, try to recreate the context. Go back to that place, listen to that song, evoke that same feeling.
It might just unlock it.
Okay, so forgetting's normal, retrieval cues are key. Got it. Any other tips for boosting our memory power?
I can't say this enough. Sleep is so important. We talked about it for consolidation, but quality sleep is everything.
Not just how much you sleep, but making sure it's restful, deep sleep. That's where the magic happens.
Exactly. Make sure you have a good sleep routine. Avoid caffeine and alcohol before bed.
Create a comfortable sleep environment.
Exactly. All of that.
Sleep hygiene is key. Got it. What else?
This might seem obvious, but it's important. Take care of your overall health. Your brain needs the right fuel, the right nutrients to function at its best.
So eating a balanced diet, getting exercise, managing stress, all that contributes to a healthy brain and a good memory.
Absolutely. And don't underestimate social connection. Spending time with people you love, having engaging conversations, that helps keep your brain sharp too.
Oh, so nurture those relationships for a happier brain and a better memory.
Makes sense, right?
It does. We've covered so much in this deep dive. It's amazing to think about all the incredible things our brains can do.
Truly amazing.
And it's not about being perfect, right?
Yeah.
It's about embracing the process, staying curious, never stopping learning.
Exactly. It's a lifelong journey.
Thanks for joining us on this deep dive into learning and memory. It's been an amazing exploration. And remember, keep those brains buzzing, stay curious, and keep learning. We'll see you next time.